Hi, I'm Ron McKinnon from WhoKnowsThisStuff.com. Today we're talking geothermal heating and cooling. I'm standing here in a typical American subdivision, homes built over the last 5 to 10 years, ranging in size from 2,000 to 5,000 square feet. These homes are all heated right now with forced air natural gas furnaces and low SEER rated air conditioners. But we're talking geothermal here today. What is geothermal? What is a loop field? We're going to discuss loop fields. We're going to show you what a loop field is. The different types of equipment that are available through geothermal, whether it's warm air or whether it's hot water. We're going to talk about costs and savings, because let's face it folks, that's what it's all about, is saving some money every month. We're going to talk about the importance of planning and design, and how important that really is, and how much it's actually overlooked. And lastly, we're going to talk about the federal tax credit that's available through December 31st, 2016, which incidentally is 30% of the total project cost. There's never been a better time to look for geothermal heating and cooling in your home. So stick with us and let's go take the mystery out of geothermal. Before we start to talk about the different geothermal loop types, let's first get a basic understanding of what we mean when we refer to the name geothermal. Geothermal systems achieve very high efficiencies. For every kilowatt of electrical power used to move the heating and cooling to and from the loop field and run the compressor, we get 4 kilowatts from the ground. This translates into 500% efficiency. The Earth absorbs almost 50% of all solar energy and remains a nearly constant temperature of 50 to 70 degrees Fahrenheit, depending on your geographical location. Working with an underground loop system, for instance, a geothermal unit utilizes this constant temperature to exchange any energy between your home and the Earth as needed for heating and cooling. In the winter, the circulating fluid inside a sealed loop absorbs heat from the Earth and carries it into your geothermal unit. Here it is compressed to a higher temperature and sent as warm air to your indoor system for distribution throughout your home. In the summer, the system reverses and expels heat from your home to the cooler Earth via the loop field system. This heat exchange process is not only natural, but it is truly ingenious and a highly efficient way to create a comfortable climate in your home. Geothermal heat pump systems consist of basically 3 parts: the ground heat exchanger, commonly referred to as the loop field, the geothermal heat pump itself, and the delivery system, whether it's sheet metal duct for forced air delivery or radiant inflow for hot water delivery. This depends on the type of equipment selected for your specific application. Design and planning of the project is where the entire process begins. This is a critical step. We need to ensure that your system has been designed properly so that it will operate properly. There are some steps that are involved in the design and planning process. We're going to cover a few of those here. Firstly, a thorough heat loss, heat gain calculation must be completed on the project. You will typically size the geothermal system to handle 95 to 98% of the heating load in northern climates. Cooling is not so much of a concern, as the geothermal heat pumps today have 2-stage compressors, where first stage will operate at about 2/3 of the full capacity when needed. If more air conditioning is needed because of the load, then second stage will engage and you will get 100% cooling with the geothermal system. Another component of this system is the design of the loop field. A thorough site assessment should be conducted to locate the field, as well as determine the soil conditions and ensure adequate space for a horizontal field. So as you can see, a proper design is critical for a system to operate efficiently and not cost any more than it should to install or operate. We mentioned at the beginning that there are 4 geothermal loop types: vertical, horizontal, lake, and open loop. Now let's discuss vertical loop fields. Large commercial buildings and schools often use vertical systems because the land area required for the horizontal loops would be prohibitive. Vertical loops are also used where the soil is too shallow for trenching, and they minimize the disturbance to existing landscaping as well. For a vertical system, holes approximately 4 inches in diameter are drilled about 20 feet apart and 150 to 300 feet deep, depending on the design. Into these holes go 2 pipes that are connected at the bottom with a U-bend to form a loop. The loop bore must then be filled with a bentonite grout to ensure that the pipe is in contact with the ground. The vertical loops are connected to a manifold placed in trenches 8 feet deep that then run into the building and are connected to the geothermal heat pump system. If adequate soil or clay-based land is available, horizontal geothermal ground loops are typically one of the more economical choices. In horizontal geothermal ground loops, several hundred feet of pipe is buried 8 feet deep in a trench and backfilled. A typical horizontal ground loop will see about 400 to 600 feet of pipe per each ton of heating and cooling. Because of the amount of trenching involved, horizontal ground loops are most commonly used for new construction. Pond and lake loops. The site must have an adequate body of water. A series of pond loop mats is constructed and placed about 1 foot off the bottom of the body of water. Obviously, weight must be added to this system to prevent it from floating to the surface. So here you can see we've got a pond. The pond should be about a ½ acre in size and at least 8 to 10 feet deep. With this pond, we would then sink or submerge our slinky loop out there with concrete blocks about 1 foot off the bottom of the pond. From there, all we got to do in this case is we'll excavate a trench all the way up to the house, about 4 feet wide and about 8 feet deep. And in this situation here, it's about 150 feet from the pond to the home. Okay, so now we're going to submerge our loop field in a pond which is existing instead of digging up the ground and burying the loop field in the ground. Okay, and then we're going to take it into the home. Significant cost savings can be realized here because now we're not excavating either 3 or 4 tons of loop field with a big bucket or opening up a large part of the ground. Okay, so the excavation costs are a lot less money. Now this is an ideal situation of which the homeowner wasn't sure. He's going to be pleasantly surprised when he finds out that we can install a pond loop here for his application and save him significant money on the installation of that geothermal system. An open loop system uses well or surface body water as the heat exchange fluid that circulates directly through the geothermal heat pump system. Once it has circulated through the system, the water returns to the ground through the well, a recharge well, or surface discharge. This option is obviously practical only where there is an adequate supply of relatively clean water, and all local codes and regulations regarding groundwater discharge are met. A typical 4-ton geothermal system will require over 1 million gallons of water on an annual basis to operate. That is also 1 million gallons that needs to get back to the aquifer. The quality of water is also critical. Water which has a high mineral content can clog the heat exchangers on the heat pump and seriously affect the performance, or worse yet, clog the system to a point where it is rendered unserviceable. A water test with an open loop system is highly recommended, as well as a strict maintenance schedule to ensure proper operation of your geothermal heat pump system. It is not uncommon to realize 40 to 60% savings on your utility bills with a geothermal heat pump system when compared with a new high-efficiency furnace and a highly efficient air conditioner or air source heat pump. A federal tax credit is available for the installation of a qualifying geothermal system. The geothermal heat pump must be Energy Star rated and include a hot water generator for domestic hot water supplementation. This credit is in effect until December 31st, 2016. For example, that 30% tax credit is actually 30% of the total project cost, which includes the loop field, the geothermal system, and the distribution system. So for example, if the geothermal system costs $30,000 to install, that equates to a $9,000 tax credit to you. Well, we certainly hope that we've taken a little bit of the mystery out of geothermal heating and cooling for you today. Our mission at WhoKnowsThisStuff.com is to do exactly that, to take this alternative renewable energy technologies that are out there and simplify them, break them down so that you, the consumer, have a certain level of comfort with these technologies, and maybe you'll look to those to incorporate them into your lifestyle to start saving some money. That's what it's all about. If you have any questions, go to our blog while you're here on our website, pose your question, we'll get back to you right away. Check out our extensive library on everything from solar thermal, solar PV, wind, biogas, switchgrass, you name it. If it's renewable, we got it right here, right now. WhoKnowsThisStuff.com, simplifying renewable energy.